exponents down. Okay, we're going to make this as painless as possible today. Let's simplify each fraction first, Bella and JJ. Let's simplify each fraction first. Let's look at just the first one. Can I simplify the x's at all? I only have one x, so I can't simplify it. What about the y's? What do I do with the y's? Do we remember? When we divide, not multiply.
Distribute.
When if it was like this, we would be adding.
Wait, so that's multiply right now?
So if it's multiplication, we add. So if it's division, we subtract. Okay, so we're going to subtract the exponents here. Okay, so 6 minus 2 on the y's. What do we get? 6 minus 2? 4. So we get x to the 4th over 8. That stays. And then we have y to the 4th out of these two. Where should we put it? Top or bottom? Which one has more right now, top or bottom?
Oh, top.
Top, so we're going to keep it on the top. Y to the 4th. That's the first one. Second one we're going to leave as it is for now because there's nothing we can combine. Okay, now when we divided, we subtracted the exponent. So when we multiply, what should we do? What do we do here with these ones? We add them. Okay, so I'm going to add all my exponents up. On the top, my negative 7 is going to stay. My x to the 4th is going to stay. I have to handle my y's. What's y to the 4th times y? Y to the
4.
What number is really right here? 1. Okay, so 4 plus 1, 5. Y to the 5th. My 8's going to stay on the bottom. And I'll keep my 8's not going to stay. What's 8 times 3?
24.
24. And then we have x to the 5th. Am I done at this step? No, why not?
I don't know how that works.
We still have these x's here, so we have to handle them. We're dividing, so are we subtracting or adding the exponents? We're dividing. Subtracting, okay. 4 minus 5. Negative 1, and since it's negative, we're going to write a y to the 1st, but are we going to keep it on the top or the bottom? Bottom, okay. So we have, x to the 1st. But negative 7, y to the 5th, 24x on the bottom. We subtracted, we got negative 1, we put it on the bottom. Questions on that little Algebra 1 review? Again, we're just doing these because you're all taking Algebra 2 next year. So we got to keep these skills up to date. Questions on that one? Okay. What we have learned so far is that to prove two triangles are congruent, we need either all three sides, congruent to all three sides. That was side, side, side. We also had side, angle, side. So two sides in the included angle, aka the angle in between the sides. And we had hypotenuse leg, where we only needed a right triangle, a hypotenuse congruent to the hypotenuse, and the leg congruent to the leg. We're adding two more today, okay? First one is angle, side, angle. So I'm going to show you that now we only need two angles and the included side. So if we hop over to this piece right here, I have two triangles, and we're going to have this angle and always be congruent to this angle, and these two angles always congruent, and this side always congruent to this side. So what we have here is angle, the included side right here, and then another angle. So this is angle, side, angle. Okay? See how this side's in between those two angles? It has to be that way. Okay? If we look over here, we have that same stuff set up. Angle, side, angle. No matter how we move this, the only way to make a triangle is going to be to make the other sides and the other angles the same. Meaning the only way that I can make a triangle with this angle, this side, and this angle is if it looks exactly like this triangle. Okay? So now we only need angle, included side, and angle. So that's this theorem here, ASA. You remember that because remember the letters stand for angle and side. So angle, side in between the angles, and then another angle. It says if two angles and the included side are congruent to two angles and the included side of another triangle, then the triangles are congruent. So here are two angles. Angle A is congruent to angle D. Okay, so that's the orange ones. Angle B is congruent to what angle? What's the same as angle B on this picture?
E.
E. They both have the two arcs. So angle E. And we have AB, side AB, congruent to side DE. So we have angle, side, angle, and angle, side, angle. You should be able to trace out your theorems like that every time. Without lifting your finger, can you hit an angle, a side, and an angle in a row? Okay? Since we did, we can then say that by the angle, side, angle theorem, triangle ABC is congruent to DEF. So all we needed was an angle, the included side, and another angle. Questions on that one? Okay. If we have Mariah, phone. Are you on your phone? Okay. It's got you back there. Okay. Right here. If we have these two angles, can I find this third angle? If I know numbers for these, would I be able to find this third one? I hope so. They all have to add to what?
180.
180. So if I have two angles, I can always find the third. So that also means for both of these, I also have this. I know that. Okay, I know that angle C has to be congruent to angle F. That's your third angles theorem. Okay? So, this kind of relates to this next theorem. Now, I don't necessarily need an included side. I just need angle, angle, side. Okay, that side doesn't have to be in between because if I have those two angles, I always know the third. So these kind of go hand in hand, and we're just switching where the side is. So if we look at that on GeoGebra, it looks like this. We have these two angles in a side set to a certain value, and we can kind of move around to see how we make our triangles. And I haven't messed around with this one a ton. Whoa. But if you switch these around, and maybe I'll play with it more later. But if you look, you're always going to get the same triangle back once you change the sides. Either way. Chromebooks away back there, Mariah. Who? Okay, so that's our last triangle congruence theorem. Angle, side, angle. Or angle, angle, side, sorry. Angle, angle, side.
Wait,
No.
that is what it's
No, it's not, because we've talked about this. If we have this side, side, angle, and we flip it in reverse and it spells something that Miss Cruz will never have you put on a test. So this is not a thing. Two sides and then an angle off to the side, we can't do that. But we do have two angles and a side. Okay, so AAS, angle, angle, side. If we look here, we can trace it out. Angle, that's the pink one. another angle, that's the purple,
Solid.
and our side, the yellow. So we need two angles in an included side or two angles in a non-included side. And depending on which side you pick, that's where you put the S in your three-letter congruence theorem. Okay? So again, here we had angle A congruent to angle D, angle B congruent to angle E, and CB congruent to EF. I hope you guys are taking notes. I'll be checking yours first. Okay, so we have angle, angle, side. So therefore, triangle ABC congruent to DEF. So now if we just have two angles at a side, it doesn't matter which side. Okay? Two angles at a side, we get congruent triangles. So these four are very, very similar, nearly identical to 4 or 6 problems on your test, okay? You have to look at a picture and determine if the triangles are congruent, and if they are, which theorem can you use to get there, okay? So I would recommend on your paper, we're just going to start circling or highlighting or coloring in the pieces that are congruent that we know. So first, I see that this angle is congruent to this angle. So I'm going to color it. I have one angle. What else do I know? What else does it show me with arcs? Not right angle. But we know that those two angles are congruent, right?
I forgot what that's called.
Those arcs show me that those two angles are congruent. And we have something hidden here. The three sides of this triangle on the top left are RU, RS, and SU. The three sides of the other triangle are TU, TS, and SU. Do they share a side? We're looking for shared sides here. Are those triangles right up against each other to where one of their sides is the same? What side? What's the name of it? What letters?
US.
Perfect. US is a shared side. So remember, no. That's your one and only warning. Don't throw things. Okay. We have a shared side. We can't forget about those. Okay, sometimes it'll only show you a few things that are congruent, and you have to realize that some of the things are the same. They share the same side or same angle. So here we have, when I point to the object, you tell me if it's a side or an angle. Okay, we're going to trace it out together.
Angle. Angle.
I'm pointing to the pink one. So angle, pink one.
Angle.
Angle, purple one.
Side.
Side. Back to this one, yellow.
Angle.
Pink.
Angle.
Pink.
Angle.
Angle.
Side.
So what you just told me is angle, angle, side.
AAS.
AAS. That's the theorem that we just used. The reason it's not ASA is because this side is not in between my angles. Okay? If it was this side instead, if it was UT, it would be ASA. But it's not. That side's not in between, so it's AAS. And now we just have to write our congruence theorem. So triangle congruent to triangle. Again, on the test, it'll say, write a congruent statement. You have to know what that means. You have to know that it's looking for a triangle congruent to a triangle. I will not be able to tell you that on the test. You need to know what a congruent statement is. Okay? So, if we look at this triangle, let's say SRU.
Which one is it?
I'm going to say SRU for the top left. SRU for this top left one.
Is this some tissue?
I just looked.
You'll have to run to the bathroom. I haven't grabbed one yet.
Yeah, I know, I can't see.
Oh, that's an
I'll
easy
grab one
fix.
for you. No, it's fine. I just looked.
I
at it.
like it.
That you can't see. I think it still gets through though. Let me just go get Oh!
Alright, you're I fine. go grab
Maybe a
some
little
tissues.
bit.
That's way better.
What? For me?
Yeah.
No, I'll get them after class. Don't worry.
Is it cold for
Because I got to get them from the
Yeah.
bookstore.
Oh my god.
Okay. Let's finish off this congruent statement here. S for this triangle, Bella focus. S for this triangle was pink. So what's pink in my other triangle? What letter? In the bottom triangle, what letter's pink?
You're the
U, yeah. So U, S goes with U, they're both pink. R is yellow. What's yellow in the other triangle? What's yellow for the bottom triangle? T. So my last letter then, yeah, S. So again, we figure out what theorem and then we match our points.
You can't use math for the lesson, right?
Correct.
Not more for that.
Correct. Thank you, JJ. Let's do another one. On this one, again, first step is just to label what you know. These arcs tell me that those two angles are congruent. Okay? The hash marks tell me that these two sides are congruent. Do we know anything else? Do these triangles have any shared sides or shared angles? Can we find congruent sides or congruent angles from these two?
Yes. No.
We don't have a way to. They don't share any sides or any angles, and we don't have any parallel lines to get congruent angles out of, so we're kind of stuck. All we have here is a side and an angle.
So that's it.
Yeah, we have an angle and a side, which isn't enough. Okay, so this one's no.
No.
We can't tell that they're congruent because we don't have enough information. We need 3 pieces, we only have 2. We would need either this angle. If I found that those 2 angles were congruent, which theorem could I use? Trace it out with me. Angle. What's this piece? Side. And what's this piece? Angle. So that'd be angle, side, angle. If we had that angle F and angle J were congruent. Or, what if we had these 2 angles? If we trace this one out, red is angle,
Angle side.
angle, side. So those are the pieces that we're missing for angle, side, angle, and angle, angle, side. We also have side, angle, side, which we could get if we had those 2 red pieces congruent. Okay? So before you say no, make sure you understand what you're missing and why you're saying no.
Do you
JJ.
have to explain? Do you have to explain? Just say no.
No, on the test you just say no.
Oh.
You don't have to explain.
Can we explain it if you want?
Sure. Sure. More than welcome to.
Do you point?
If like you say no and it's supposed to be yes, but your explanation is right, I would give you partial credit, yeah. Okay? Any other questions over these types of questions on the test? Okay, let's do 2 more. Again, I'm going to highlight what I know. First thing, my congruent arcs show me that angle D and angle B are congruent. Bella. That's really all I have that it shows me visually. So we're going to look for shared sides, shared angles first. Do I have any shared angles or sides between this triangle and this triangle?
Yeah.
Which one?
AC.
AC, okay. So I know that I have a side congruent to a side right there. Okay? I need one more piece. I need either an angle or a side. Do we remember what these 2 arrows mean?
No, I don't think I've ever seen those.
You have seen those last unit. Means parallel lines. So we're looking for shared sides, shared angles, and parallel lines can also give us congruent angles. Yeah, if we look up there, the 2 angles that we could be missing would be this angle and this angle. What's the relationship between those 2 angles? Are they inside or outside the top and bottom line? Inside. They're in between these 2. And then if that purple line is my transversal, are they on opposite sides or the same side?
Opposite.
Opposite. So these are alternate interior angles. We have this kind of situation here, where my angles are right here. Alternate interior. Bella, if I ask you to turn around again, I'm moving you. Alternate interior angles based on our poster are what? Congruent or supplementary? It's on our poster. Don't guess. Tell me based on the poster. Alternate interior.
I can't see.
It is the blue one.
Alternate interior.
Congruent or supplementary? What's it say? Congruent. Okay, they're congruent. Perfect. So now I have, based on alternate interior angles, I have those two pink angles congruent. Alternate interior angles. So if you think you don't have enough information, you need to check for shared sides and shared angles in parallel lines. Before you say, no, we can't prove that these two triangles are congruent, you have to check for those two things. Okay. Let's trace out what we know. This orange piece, what is it?
Angle.
Angle. Pink?
Side.
Pink?
Angle, side.
Angle, and then purple is side. Same thing over here. Angle, side. Okay? So the theorem that we're using is the angle, side theorem. Okay. Now we have to match our points. Let's do A, B, C, and something else. If we look at A on the triangle on the right, ABC, A is pink. What's pink for the bottom triangle? C. Notice how A doesn't always go with point A. It might be switched around, okay? So pink, A and C. B was orange. What's orange on the other triangle? D. So B goes with D. And then my last step is just point A.
Good job.
Okay? You will see I'm giving you a massive hint right now. Hint, hint, wink, wink. I would put a very big star next to this picture. If you did not just put a star next to this picture, you are refusing my help. Put a star next to it. It's an important one. It may or may not show up on your test. Okay? So I would put it on your cheat sheet. Let's do one more of this type. Again, we're going to highlight what we know. I'm highlighting my congruent arcs. I have angle D congruent to angle G. I also know these two angles are congruent. Real quick, what are these two angles called? Vertical angles. Vertical angles are always congruent. So it might not actually show you these congruent symbols. You might have to realize that yourself. Okay? So we have that. And we have this side congruent to this side. So, Bella and JJ, let's split. Okay, if I remind you one more time, we're done. And then if I remind you twice, I'm giving you an attention. Okay, let's see what we have. Pink, what is it? Angle or side? Angle. Teal, what is it? Side. Yellow, what is it? Angle. Back down here, pink is a angle. Teal is a side. Yellow is a angle. So what theorem did we just trace out? We did angle, side, angle. So angle, side, angle. And now we just have to match our pieces in our congruent statement.
One more.
So let's do triangle DEF for the top one. You can pick any order as long as you choose the order of the next one carefully. Okay? So I randomly picked DEF, and now I have to be careful about the way I order my next triangle. D for my top triangle was pink. What's pink for my bottom triangle? G. So D goes with G. They're both pink. E for my top triangle had nothing on it. It was just white. So H has nothing. This is why I like to use colors because it's easier. Yeah, and then F for my top triangle and F for my bottom triangle. Questions on those?
How many more pages?
We have 4 proofs to do. I'm going to give us a choice. Do we need a 3-minute brain break?
Yes.
Yeah, I would appreciate
Can I talk to
it.
you?
You can talk to me for sure. Let's do a 3-minute break.
Okay, can I have about 10?
Go to the restroom if you need to go to the restroom. Talk to me if you need to talk to me. And then we'll reconvene at 8:12. 8:12. It's 8:09 right now. Or you try to tackle a proof. Again, a reminder, there's going to be one on your test. And it's only going to be, listen, it's going to be fill in the blank. But there's not going to be this many blanks filled out for you. Okay? So we have to know what we're doing. Step 1, when you see a proof on your test, it'll be on the last page. Step 1, get out some colors and label the things that you have. Okay? So we're going to label GF congruent to GL. That's my teal pieces. Step 1. Step 2, it also says I have parallel lines. If I see parallel lines, I automatically know somehow I'm going to get congruent angles eventually. So again, anytime you see parallel lines, you should be thinking congruent angles from that poster.
Yeah, whack myself.
Okay? And on the test day, I'll move the poster down so you can see it better.
Whack like my top.
Whoa.
Are we ready?
Yeah.
Whoa.
Huh? Cole, put your Chromebook away for a bit. Huh? Okay. I've labeled what I know. Like JJ said, this piece, it came from my given statement, so it's given. Those first 2 lines are 2 free points out of the 5 points this proof would be. 2 out of 5. Just for writing given.
What happened to that kid that said up
Logan Duffy.
there? Yeah.
He's just gone for a bit. He'll come back.
Cool.
Okay. Given. Next line. Focus, because again, this one is very similar. Mariah, JJ, and Bella. Split yourself. I'm tired of it.
I'm gonna.
2 of you split off.
I got it. I need to concentrate.
I need 1 more. Choose the high top.
You want to move? Or you want me to move? You want to move?
Someone's got to do it.
I'm gonna do it.
Good stuff, Max. Way to take one for the team.
Yeah, because I'm a bigger person.
All right.
I don't have to play
And mentally.
Regroup. Let's see where we're at.
No, big one more warning. We gotta test you guys.
The next line says angle F is congruent to angle L. Let's label that, and our job is to figure out why. Okay? Here's angle F. Here's angle L. I want you all to color in angle F and angle L on your paper. And then I want you to turn your paper like this to where L and K on the top are on the top. What angle relationship is between F and L based on that poster? Are they inside or outside?
Outside.
Between these 2 lines, inside or outside? Inside.
Inside.
Opposite sides or same side? Opposite. So what are they? Alternate interior. So the theorem for alternate interior angles tells us that they're congruent. So this will be on your cheat sheet, but alternate interior angles theorem. So again, if we have parallel lines, we're looking for alternate interior angles or corresponding angles or some angle relationship that's congruent. The next line says we use the vertical angles theorem. So I'm going to look for vertical angles in my picture. Can someone show me with their arms what vertical angles look like? I like Amori's the best right now. Yeah, everyone look at Taylor. He's pointing to the angles in your X shape that are directly across from each other. So my top and bottom angle here, or my left and right. Perfect. So here is my X shape. It's right in the middle. I'm looking for 2 angles directly across from each other. That's these 2. So these 2 angles here are vertical angles. I just have to name them and say that they're congruent. Hunter, turn around for me. So let's trace out these angles and name them. First one, if I start here, what letter am I pointing at?
F.
G, H.
H. So that angle is FGH. If I start on the other side,
LGK.
LGK. Perfect. We're getting faster. So again, it told us we're going to use the vertical angles congruence theorem. I picked 2 vertical angles that I saw and said that they were congruent. Hello.
Lexi,
Hi, girl.
Is that an erasure?
Then my last piece. I have to figure out what theorem I used, meaning angle, side, all the things. So we're going to trace out our triangles again, and you're going to tell me if I have a side or an angle.
Yeah.
So let's start at orange. Angle, teal,
Side.
purple,
Angle.
angle. Start again.
Side.
Angle.
Side angle.
So angle, side, angle. Asa. That's right. Asa. So again, if we do this step by step. Step 1. Write down your givens and label them. Okay?
It smells musty in here.
Can I grab some colors really quick?
Yeah, they're right back there. Step 2 is figure out what you're missing and if you can find it. Meaning if you have parallel lines, you're looking at angles. If you have shared sides or shared angles, you're using those. Okay? And then the very last step, when you've shown all of your things, is to trace out what you have and write your theorem. Okay?
Can I go fill this up?
Yeah, quickly. Let's do another one. Number 3. First thing, before I even do anything, what should I put in the first 2 lines? Given. Okay. Again, those are 2 free points on your test. I am just copying down exactly what it tells me.
Wait.
Yeah.
So for the one that we did 2 days ago, when there were like 2 givens, why didn't we do like?
I was just lazy. I wanted you to do it like this.
Okay.
That one had like 4 different givens,
Okay.
so I pushed some of them together because I was not wanting a 12-line
Alright.
proof. But on your test, you'll you'll do them separate.
Alright.
One proof I had 2 givens in the same line, and he asked why.
Oh, yeah.
Why don't we write statements and give it?
Haha.
Yeah, statements.
Even better. Statements and reasons. Yes. Even better. Awesome. Okay. Good stuff. Now, it says we're using, well, first, let's label what we know. What does this symbol mean?
I know it.
Not parallel.
Perpendicular.
Perpendicular. And what do we know about perpendicular lines? What's this angle? This angle. Not 180. 90. Okay. So I'm going to draw a box in my corners here. It says QS is perpendicular to PR. So I'm going to draw my boxes. Okay. It also says angle PQS is congruent to SQR or RQS. So I have these 2 pieces. That's all I know. My next line says I'm using the reflexive property. I would put this on your cheat sheet. We're using the reflexive property when we have shared sides or angles. Meaning I can say A is congruent to A because A is in both of my triangles. It's a shared angle. So in this case, we need to look for shared sides or angles. Do these 2 triangles have anything in common? Yeah, QS, line QS. It's the same. So this is a shared side. So what I'm going to say is that since this is a shared side, I'm going to say QS is congruent to QS using the reflexive property. Okay, so we use the reflexive property for shared sides or angles. It then says that this angle, my boxed angles, are right angles. How do we know that they're right angles? Because that wasn't given to us. What was given to us was that those lines were perpendicular. Do perpendicular lines give us right angles? Yeah, and they always do. So the reason we can say that they're right angles is by the definition of perpendicular lines. Because perpendicular lines always give us right angles. We went from line 1 to line 4 here. Back to back, they related. Then it went from, okay, they're right angles, now they're congruent. If we go up to the other days of notes, maybe.
Oh, so they never delete.
No. Maybe if I can find what I'm looking for. This is what I want. Okay. Do we see anything on here that says something about right angles being congruent? Because this is exactly what it's going to look like on your cheat sheet. These exact words. And your job is to fill in what they mean. Okay, so do we see anything about right angles on here?
Yes.
Where?
The supplementary.
Okay. Good try.
Where's
Very
supplementary?
bottom of middle.
That's not right angles.
Left to the left of that.
All right angles are congruent.
You almost had it.
You can say all right angles are congruent, or I would recommend right angles congruence theorem. There's a theorem for it. On your cheat sheet, it's going to say right angles congruence theorem. And underneath it, I want you to write all right angles are congruent. Okay? So that's the theorem that we're using. We go back down. We say since we had right angles by the right angles congruence theorem, all right angles are congruent, so they have to be congruent. And I'm going to label them that way. I'm going to color them in. Those two yellow angles are the same. Now I trace out my triangles and see what I have. Do I even need to match my points up? Do I need to spend the time trying to match up my points? Why not? You're right. It is given. Yeah, it's right here. I don't even have to waste the time trying to match up my points. I'd focus right now. I don't have to match up my points because I'm just going to bring this down here. It's the same. That's what I have to prove. So that's always going to be my last line. We could have put that in at the very, very beginning because we know it's going to be our last line. Our job is to figure out how we got there. It tells us where we need to go. We have to figure out how. Okay? That's when we look at our colors. Starting at the purple. Say it with me. Angle or side?
Angle.
Angle. Orange. Side.
Angle.
Angle. So angle, side, angle. And again, the way we trace is the ones that are like right next to each other. I didn't want to go from this angle all the way around to this angle. I wanted to go through the side when I traced it out. Questions on that one?
We have one more.
Two more. Flip over. We're now on the last page. Two more proofs and then we're done.
Are you ready to make ours now?
These ones are more like the ones on your test. The ones on your test only have 2 things filled out of 5. Okay? So we're going to make our chart, statements and reasons. And we have 2, yeah, like JJ said, we have 2 givens. So lines 1 and line 2, I'm just copying down. LKM, congruent to NMK. NKM, congruent to LMK. This is a 4-line proof. If you put those 2 lines, you've gotten 50% of that proof correct. Do not leave the proof blank. Even if you don't know exactly what to do, don't leave it blank.
How would you know how many lines the proof is?
I'll tell you on the test. I'll do it based off of points. Like on the test, this would have like 4 points right next to it, and you'll just know 4 lines. But I'll tell you verbally too. Okay? But before you start the proof, typically you don't know how many lines it is. It could be 20, who knows? But
We have to put the statements and reasons.
I don't care if you label it, no. You should, but I'm not going to count off. Okay, step 2, color in what I know. LKM is this angle right here. If I trace it out, LKM.
Yeah.
NMK is this angle. Boom. And my other 2 angles, NKM and LMK, the pink ones.
Don't forget the proof. Given proof, the finish.
Oh yeah, we can fill that out too. We can fill out line 4 already as well. Not the right-hand side, but what's going to be my statement for line 4? What I'm supposed to prove. So on your test, if you fill out just that proof part as well, that's a half point. So you're guaranteed however many givens plus a half point if you just fill out the things that are typed on the test. Okay? Okay, our job is to figure out how we can prove these. So I don't have parallel lines, so I don't have any more angles, but let's try to get a side. Do any of these triangles share a side?
Yeah.
Which side?
The left side.
They share KM. Yeah, this one right here.
See, I told you.
Right in the middle. So I'm going to highlight it.
I drew on the wrong side.
And I'm going to say KM congruent to, in this case, we have to switch the order MK. KM goes with MK. But what I said is that something is always congruent to itself. What property did I use? Reflexive. And in general, we always use reflexive for shared sides or shared angles. So if you need to put that on your cheat sheet, reflexive, shared sides, shared angles. Last piece is figure out what triangle theorem I used. So say angles or sides with me as I trace it out. Angle.
Side. Angle.
Angle. Perfect. Angle, side, angle. Questions on that one?
No.
One more. We're almost done. And then we all get candy. Okay. I'm going to set up my proof first with my statements and my reasons. This one has 5 lines if you want to fill that out. 5.
6, 7.
Oh, so close. You want me to make 6 or 7 lines?
No.
6 or 7.
I can. So I'm kind of preemptively just filling out my proof.
Mr. Cruz, is your homework lesson 6, 7?
Yeah. All of math is, yeah. All of math is doing something with 6, 7.
How is it?
I know. What?
It's a pen.
How is it on my shirt? Safety pins. That's it. Okay, back up here. Power through with me for the very last proof. Okay. How many givens am I going to have? How many lines? How many lines of givens? 2. Okay, so given, and I'm just going to copy down these 2 statements in my given column. So it says HF parallel to GK, and it says angle F and angle K are right angles. Those were all given to me. 2 out of 5 free points on this proof. I can get another half point for free if I do what?
Write the proof down.
Write the actual thing that I'm proving down. So I'm going to write this statement on my very last line.
So the proof will always be last.
Yes, the prove part is always last. The given part is always first. So now I have 2.5 free points out of 5. 50% for doing essentially nothing, for copying down. Okay. We're going to label what we know. Actually, from our given statements, I have nothing congruent. I have parallel and I have right angles. So I actually can't color in anything yet because I don't have congruent statements. But
Right angle.
parallel, okay, we can do right angle.
Shut up.
JJ wants to say that these angles are congruent because they're right angles. We just used that theorem in this proof. What theorem did we use to say all right angles are congruent?
The one that all right
It's-
angles.
It's
That one right there.
when?
Right angles are here.
Right angles congruence theorem. So
I would keep your butt.
I'm going to say just angle F is congruent to angle K. I don't need 3 letters because there's only one angle K and one angle F. But that's by the right angles congruence theorem. Okay, now let's see if I have any shared sides or shared angles. Do I have any shared sides? Yeah, GH, and I lied. This is actually a 6-line proof. But I'm going to say GH is congruent to GH. And when I say something is congruent to itself, what property am I using? Reflexive. So we use the reflexive POC, property of congruence. I did lie to you.
Gosh, dang.
But now I can highlight this side.
That's 6.
You just break it.
You said there's only 5.
I know I lied.
So there is 6, 7.
There's 6.
7.
We could make it 7.
No.
I don't want to. Okay. Okay. I have an angle and a side. I need one more thing. And that one thing is going to come from parallel lines. The only given, bless you, that I haven't used. So if we notice, we use the right angles part of my given. Bless you.
Bless
We
you, Josh.
haven't
Drink
used
it.
this part. Focus, because this is one like your test. We have not used the parallel lines. Parallel lines always will give you angle congruent to an angle. And we just have to figure out what angles are congruent. So up here, if I label these two angles, the purple ones, are they inside or outside my parallel lines? Inside. And are they on the same side or opposite sides of my transversal?
Opposite.
Opposite, so what do I call them?
Same side opposite. Inside opposite.
Interior and alternate interior, opposite side. So by the alternate interior angles theorem,
Get on my level legs.
those two purple angles that I marked are congruent because they're alternate interior angles on parallel lines. Let's name these angles, JJ and Max. I'm going to trace it out. Name it with me.
Angle, side,
FGH. We're naming the angle right now. We'll get to that. FGH and
Wait. K, H, G.
KHG.
Twice a day.
So again, I used up all my given statements besides my parallel lines one. And parallel lines always gives me congruent angles. Last step is to do what JJ wanted to do. We're going to trace out what we have.
You just go right there with five.
Okay. I'm going to trace out what we have. I'm going to start on the yellow.
Side.
Angle.
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 Angle. What you just told me is side, angle, angle. Is that a thing?
I said side, angle, side.
We don't have two sides. We only have one. But is saw
It's
a thing?
angle, side, angle.
No. But if I flip it and reverse it,
Angle, side.
angle, angle, side. If I started over here, angle, angle, side. So just be aware, if you trace out your angle, side, angle, or whatever, and the order looks weird, flip it around and see what you get.
Are we done?
Yeah, we got to fill out this last piece. And I want to talk real quick about your test. So, on your test, that poster will be up, but you also need to know those things. What I would highly recommend doing for your test is straight up copying this and putting it on your cheat sheet. This is basically everything you need to know from sections 4.3, 4, 5, and 6. Okay? So that needs to go on your cheat sheet. I also want you to fill out on the typed part of your cheat sheet. I want you to write down what those theorems mean. Okay, so I have those copies if you want them early. If not, you can get them on Monday.
Wait, the cheat sheet, can I get them today?
So that's all we have for today.